Hello lads, this is to go through question 9 on page 216. Okay, there's something I didn't go through with you in class. Thanks Lucas for reminding me. It's to show that something tends to a limit. Okay, so I'm just going to do some of this question for you and demonstrate how to do the part that asks for that limit. Right, so this is where you've got a particle. It's a set distance d, so that's d away from O. And the force applied is 2m over x to the 5. So we put it into our force equation. The m's cancel out. What we're interested in here is the distance and acceleration. Nothing for time, so we don't use dv dt. So we've set it up like this. Okay. I've used x because x represents the distance it's travelled. Okay. It also represents part of the acceleration, part of the expression for acceleration. Okay, so dv dx, which is the distance in this case, that's the not dv ds, dv dx. Jiggle it around, and that's your setup, right? Now the question asks for the velocity when the distance is at square root of 3d. So that's where you go for the first part of the question. Now, for the second part of the question, this is important, right? The second part of the question is basically asking us, I'm just going to show you how to do this, and there's an example, read the example as well. So that's the same thing, but instead of having the square root of 3d, I've got x there, right? Because x is the distance, right? So we're looking for basically a general equation relating v to x in terms of d. Right, so this is like, it didn't give you a specific velocity, distance like the first part. So if I just go through this and integrate it, right, should be able to do this step now. I get to here, subbing in v and 0, v squared over 2, x and d, 1, right, and multiplying everything by 2, cancelling the 2's. I end up with this, right? So I'm trying to cover the rest of it because I want to do this myself. Right, so I end up with v. In general terms, this is the only thing that's changing. D was the initial distance from O. X is the distance it's travelled since then. Right? So when it says, what does v tend towards the more he goes on the journey? Well, the further the particle moves, the bigger this is going to get, isn't it? So the further the particle moves, the bigger this is going to get. So show v tends towards the limit of 1 over d squared. So we notate that something like this. Focus please, camera. Okay, so as I said, x is the thing that's moving. The more he moves, x is getting bigger. So we would write it, excuse me, second there. Right. So as, and you'll do this in your maths course as well, you might have done it already. As x approaches infinity, i.e. as x gets bigger, 1 over x to the 4 approaches 0, doesn't it? Because the denominator is getting bigger. Okay. Therefore, v approaches. So if this becomes 0, that goes away basically. The square root of 1 over d to the 4, which is 1 over d squared. Square root of 1, square root of the rules of surds. You can separate the square root. Okay. So there you go, lads. Sorry, I meant to say that the other day. So I'm just putting it up there now.